So here this is the problem. This AB is actually a link. AB is a link, and at point A there is a ball and socket joint, at point B there is another ball and socket joint, and this CB is a crank. So CB rotates about this axis with an angular velocity omega 1, and omega 1 is 6 radian per second and constant at this instant. This DA is another crank which rotates about the vertical axis with an angular velocity omega 2. Omega 2 is not given, but here omega 1 is given, and once omega 1 is given we can find out the magnitude and direction of the velocity VB. For VA we know the direction because we know omega 2, and this distance is also given, but omega 2 is not given, so we know the direction of VA, but the magnitude of VA is unknown. And we have to find out the angular velocity of the link AB which is denoted by omega n vector. So this is the first method. So what we do actually here, what happens here, this x, y, z axis, this x, y and z axis are parallel to the inertial reference, and it is translating with respect to the inertial reference with the velocity VB. So we can take, or we can define the rotations with respect to x, y and z. So this is the link spin axis, this is the symmetry axis of the link. So this is the symmetry axis of the link, and the link spins about this axis, and the link spins about this axis, and this is the inertial z axis, or rather parallel to the inertial z axis. So first this plane is located, the plane containing this z, the plane containing z and z double dashed is located, and x and z, once z is known, z is parallel to inertial reference, we know that small x and small y are perpendicular to z, and once this plane containing z dashed and z double dashed is located, we can find out the nutation angle theta, and the x dashed axis, that is here, do not bother about the names because in some problem it will be called x dashed, in some problem it will be called x. So and here this one small x, in some problem it will be called capital X. So do not bother about names. So just remember this small x, small y, small z are parallel to the inertial references, inertial coordinate system fixed to inertial reference. So and once we get this z and the spin axis, we can identify this plane, and from here to here is the angle theta, the nutation angle, and the perpendicular to this plane is this nutation axis. So theta dot takes place about, theta dot angular velocity is along the nutation axis, and the rotation theta takes place about this nutation axis. So the rotation theta takes place about this nutation axis. Now we have to locate the nutation axis with respect to x, and for that we have to give a rotation psi. The precession psi is the precession angle about z. So x comes here. So this psi is the precession angle, and this theta is the nutation angle. And once we identify psi, psi dot will be perpendicular to this, and theta dot is along this. So and here you see, we assume that the link is not spinning, that is phi is 0. So the angular velocity of the link can be specified as psi dot along small k, so small k is along small z, and theta dot along x dashed, so theta dot along I dashed. So this is the angular velocity, and here once we specify the angular velocity, we see that there are two unknowns, psi dot and theta dot, and I dashed is along this. I dashed unit vector is along this. So that is cos alpha in the minus I direction and sin alpha in the plus y direction. So minus cos alpha sin I plus sin alpha j, and alpha can be found out. This is 50, so this is 50, this is 100, so tan inverse 50 by 100. Similarly you can find out that theta equal to tan inverse, so this length is 100 square plus 50 square square root, so 100 square plus 50 square divided by this divided by this, so this is 100. So you can also find out what is your theta. So now you know omega n is this, and BA is from here to here, so this is 50I plus 100K plus 100J. So B2A is this is 100J, this is 100K plus 50I. So now what is the velocity of VA? The velocity of VA is VB plus omega of the link cross BA. So VA equal to VB plus omega cross of the link cross BA, and VA is 50 omega 2 because 50 is the length of the crank and omega 2 is the angular velocity. So VA is 50 omega 2 and it is in the positive J direction. So 50 omega 2 J is equal to 600I. VA is 600I because VB is 600I. VB is 600I because this is 6 into 100. Omega 1 is 6, this is 100, 6 into 100 in the positive x direction, and this is omega n cross BA. So here we have three unknowns, omega 2 is one unknown, and theta dot is one unknown, and psi dot is another unknown. So from these three equations you find out theta dot equal to 0, psi dot equal to omega 2. Psi dot and omega 2 are same and they are 6 radian per second. So the angular velocity of the link is 6k radian per second square, because angular velocity of the link is this. So theta dot has been found out to be 0, so this is psi dot k, and psi dot is 6. So the angular velocity of this is 6k radian per second. So this is the answer of the problem. But in the book what is done is, as we have taken omega n as psi dot k plus theta dot I dashed, in the book they have taken omega n is omega nx I plus omega nyj plus omega nz k, because they have not tried to express it in terms of the rotation of the link. And then they use the same relation, V equal to VB plus this. So again the same equation, only the omega is different, but here the number of unknowns 1, 2, 3 and 4. So from here we get 3 scalar equations, because one vector equation gives you 3 scalar equations. So another scalar equation you require. So that scalar equation they have got by taking the dot product of omega n with AB as 0. That means they are assuming that this omega has no component along AB. So they have assumed this omega has no component, omega n, that is the omega of the link, has no component along AB, and using this they have found out this relation. So omega 2 from both the methods are coming same as 6 radian per second, but omega n is different. So see, this is the comparison of the two methods. So omega n is 6k from method 1 and omega n is this. But if you take omega n cross BA, and you know this is the relation VB minus VA, actually VB minus VA depends on omega n cross BA. VB minus VA depends on omega n cross BA, and omega n cross BA, whether you take this as your omega n or this as your omega n cross BA is same. So both the results are giving same value of omega n cross BA. So there will be no effect on VB minus VA whether you take omega n as this or omega n as this. So both the results are correct. Now why is this difference coming in these results? The reason is that in our case omega n is this, and if you take omega n dot BA, it will not be 0, and here omega n dot BA 0. That means they have taken 0 component of omega along the axis of the link, but we have taken 0 phi. We have taken phi, the rotation about the axis, as 0. So see, the omega n, that is the angular velocity of the link, can be broken up into two components. One is omega n along BA and omega n perpendicular to BA. So if you take omega n along BA and omega n perpendicular BA cross BA, then omega n along BA cross BA will be 0, because they are omega n along BA cross BA, they are in the same direction. Omega n along BA cross BA, so BA and omega n along BA, they are in the same direction, so the cross product would be 0. Only this component will remain. So whatever value you take, whether you take omega n, this is actually omega n along BA, so this is actually omega n along BA, this is omega n along BA. So whether you take omega n BA along BA is 0 or non-zero, that will not have any effect on the cross product. So that will have no effect on the cross product omega n cross BA. In the book they have taken omega n cross BA 0, we have taken omega n along BA not equal to 0. And in our method, so what is the relation between the omega n's obtained from both the methods? So the Merriam's method, that is whatever is done in the book, omega n in method 2, that is omega n in method 1, and you have to subtract the along component from it. This is omega n method 1 dot eta BA. Eta is the unit vector along BA. So this is the component of omega n along BA. Omega n along BA. This is omega n along BA, and this is the unit vector in the direction of BA. That means the omega n which you compute from method 1, that is which is 6k, minus the along component gives you the omega n for the method 2.